In this video, we'll be looking at from our textbook BVD 4th edition, page 408, number 12. This is from chapter 15. Pause the video and read the problem 2 times. This problem, looking at the question sentence, says find the man's expected profit. Well, the expected profit is our expected value. This is from the formula chart. We can call it the mean of x, the mu of x, or the expected value of x. It's the sum of each outcome times the probability. I'm defining my random variable x to be the profit from the sale of the horse. So I'm going to make myself a table now. X are my particular profits. I can have an $80,000 profit because it says I'll sell the horse for $100,000, but it cost me 20, so 100 minus 20 gives 80. I could have a profit of $30,000, selling my horse for $50,000, but paying the $20,000 is a profit of 30, or I can lose $10,000. I only sell my horse for $10,000 and I paid $20,000 for it. So these are the particular values subtracting off what I paid because I'm interested in the profit. Now I just need the probability associated with each one of these. Okay. It says the man believes there's a 20% chance he will win the first race and a 30% chance he will win the second one. Assume the 2 races are independent. Well, if they're independent, we can multiply to define the compound event. So it's saying the probability that he wins the first race is 20%. The probability he wins the second race is 30%. The probability that he wins both of them, first and second, intersection, this is and, looks like an A. Since they're independent, we simply multiply these two. It's 0.2 times 0.3. Well, that is 0.06. This is a probability that he wins both of them. Let's look at a Venn diagram. It could help for further understanding this problem. Okay. This is my first race. This is my second race. And here is the overlap. When we do our Venn diagram, we start with the overlap. 0.06. That's in my intersection. Well, the first race, we have a 20% chance, but we've already got this 0.06, so what's left over here is a 0.14. This 14% is the chance that he wins the first race, but not the second race. So the second race circle is 30%, but we've already used this 0.06, so it's 0.24. This is the chance that he wins the second race, but not the first race. Okay, what's left over out here? Winning neither race. So we need to sum these and then subtract from 1. So that's 0.2, 0.44. 1 minus that is 0.56. He has a 56% chance to win neither. Okay, and you can look at the formulas on the formula chart to help find these, but I think the Venn diagram is really useful in this case. All right, so minus 10,000. This is losing both races. He's going to lose both races right here, 0.56. Losing both races. 80,000 is winning both. Well, that's this intersection. 0.06 is the and. Well, this must be the leftover. It must be the rest. If I add 0.56 and 0.06, that's 0.62. So the rest in here must be 0.38. Let's see if we can come over here and see where that 0.38 is. Well, what's this? 0.14 is winning the first only. 0.24 is winning the second only. If I add 0.14 and 0.24, I get that 0.38. So you can see these are the 3 possible outcomes. This is losing both, this is winning both, this is one of each. All right. So our expected value, mu of our x, is equal to each one of these multiplied together and added. So we're going to take 80,000 times 0.06 plus 30,000 times 0.38 plus negative 10 times 0.56. So multiplying each one of these and summing, I come up with 10,600. This is our expected value. We won't ever get 10,600. We're going to get a profit of 80,000, a profit of 30,000, or a loss of 10,000. But over the long run, if we did this over and over and over again, our average would be 10,600. All these 80,000s, all these 30,000s, and all these $10,000 losses together would be 10,600 positive. We're doing pretty good. We're winning. We're going to make 10,000 bucks every time we sell this horse. Pretty sweet deal. Yes, we lost 56% of the time, but when we won, we did much better than this amount that we lost.